Hello everyone. Today I'm going to discuss the G's problem of Codeforces around 970 division 3, which is Sakurako's task. So what is the problem? We are given an array A of n integers, and what we can do, we can choose any two integers I and j such that I is not equals to j, and assign ai minus aj or ai plus aj to ai. We can perform this operation any number of time. After the operation is done, we have to find kth max of the given array. So what is kth max? For that, let's take one example. Let's say the given array is 1 3. Now we don't perform any operation. Now let's say the value of k is, let's say, 3. So what is the third max of the given array? Now what is a max? That is the first thing to understand. Max of an array means that the smallest non-negative integer which is not present in the array. So what is the smallest non-negative integer that is not present in the array? So that is 0. So we can say that max of 1 is 0. Now what is max of 2? Max of 2 means what is the max after adding 0 to the array. So if we add 0 to the array, what will be the max now? The max will be now 2. So max of 2 will be equals to 2. Now let's add 2 here. Now what will be the max of 3? Max of 3 means that what is the what is the current max after adding 0 and 2 to the array? The current max after adding 0 and 2 to the array is nothing but 4. So max of 3 is 4. For k equals, for the value k equals to 3, our answer will be 4. Okay. Now what is the operation we can do? We can choose any I and change ai to ai minus aj or ai plus aj. So let's say we have 1 comma 3. Now let's say we have chosen this as I and this as j. Okay, so let's say this is I and this is j. Now we'll change ai to ai minus aj. Now our array will become 1 comma 2. Now let's again choose this as j and this as I and perform the operation again. So now this will be 1 1. Now let's do the same operation again, choosing this j and this I. Now the array will become 1 0. Now what is the max 0 of this array? The max 0, now the array is 1 0. Now the max 0 is nothing but, sorry, max 1 is nothing but, the current smallest non-negative integer that is not present in the array, that will be 2. Okay, max 1 will be 2. Now what we have to find? We don't have to find anything because that is not in our test case. Yeah, this is in our test case. We have to find max of 1. So max of 1 is nothing but 2. Okay, I hope you get it. Max of 1 is 2. I think I am missing something. So this is not the test case. So let's take one actual test case which is given in our problem statement. Let's take this 1 2 3. Okay, let's take 1 2 3. What is the test case number for this? The test case number for this is 30. So we have to find max 1 for this test case. So what will we do? We'll choose let's choose this as I, and let's choose this as j. Okay, now the array will become, if we perform ai minus aj, the array will become 1 2 and 1. Okay, now let's choose this as j and this as I. Now we'll do again, perform ai equals to ai minus aj. Now the array will become 1 2 0. Now what is the max 1 of this array? Max 1 means what is the smallest element that is not present in the array? The max 1 will be nothing but 3. So that's why our answer will be 3 here. Okay, I hope you get it. And now I will not going to explain the other test cases. Now what is important for this problem? For this problem, the important thing is to understand the Euclidean algorithm and know about what the Euclidean algorithm says and what the extended Euclidean algorithm says. So let's say we have some two integers x and y. Okay, now what we can do? Okay, we can use take another two integers a and b, such that a and b are integers but not necessarily greater than 0. They could be less than 0 also. So we can say that we can achieve ax plus by as k into g. So k is nothing but a integer, positive integer, and g is nothing but gcd of a comma b. Okay, g is nothing but a gcd of a comma b. Okay, that's what extended Euclidean algorithm says. So you can check this. I will provide the link of the this Euclidean algorithm article in the description box. You can check that out. Now, how will this algorithm help us? Okay, how will this algorithm help us? Now, what we can say that if we find the GCD of the entire array, then we can arrange them in this order. Okay, let's say our GCD of the entire array is G, so we can arrange them in this order: 0, G, 2G, 3G, like that, like n minus 1 into G. Okay, if the GCD of the array is G, we can arrange the elements in this order: 0G, 2G, 3G, and n minus 1 into G. Obviously, if one edge case is that if n is greater than 1. Now, if n equals to 1, we can't have this 0. Okay. Now, this is the most important part for this problem, that if we have some GCD G, then we can arrange, we can have all these elements in the array. We can have all these elements in the array, and there is no way to have something like G minus 1 or 2G minus 1, like that. Okay, there is no way to have that. Now, as far you can see that if G equals to 1, we can obviously arrange them in like this order: 0, 1, 2, 3, 4. And we have another test case, let's say 2, 2, 2, 16. Let's take this test case to understand this better. So let's take 2, 2, 2, 16. Okay, 2, 2, 2, 16. So what I told you is that we can make that into 0, 2, 4, and 6, because GCD of the array is nothing but 2. Okay, so the first operation we will do, choosing this as I, and choosing this as I, and choosing this as J, and performing AI equals to AI minus AJ. Now, so the array will become 0, 2, 2, 16. Okay, now let's choose this as I and this as J, and do AI equals to AI plus AJ. So the array will become, sorry, okay, some lag here. So the array will become 0, 2, 4, and 16. Now what we will do, we'll continuously subtract this 2 7 times from 16. The array will become, sorry, not 7 times, we'll subtract this 5 times. So the array will become 0, 2, 4, and 6. So we have this as our desired out sequence. Now, after having this sequence, we have to find the kth max of the array. That is another part. Okay, so the first part is that we can have this in this format: 0, G, 2G, 3G, and n minus 1 into G. Now, after that, we have to find mix of the array from this given sequence. Now this part is quite straightforward. So, what are the number of elements in this part? The number of elements in this part is nothing but, let's consider 0 and 2. So, number of elements in the interval is nothing but G minus 1. So, are other G minus 1 elements here also. So, like that, we'll have G minus 1 into G minus 1 number of elements here. Now, at each interval there are G minus 1 elements. Now, when let's say the value of, let's take this one only, 0 to 4, 6. We have 0, 2, 4, and 6. Now the value of k is nothing but 3. The value of k is 3. Okay, here let's take what is the value of 3. Sorry, the value of k is 5. Okay, the value of k is 5. So what are the number of elements here? The number of elements here is 1. What are the number of elements here? The number of elements here is 1. Here also there is 1. So we have already 3 elements. So after that we have place of 2 elements. So we'll add 6 plus 2 here. So 6 plus 2 will be our desired mix. Now let's say if the value of k is equals to 3, then our answer will be, we have found one element here, one element here. And if the value of k is 3, then our answer will be 5. I hope you get it. Now let's jump into the code. You will understand it better. So what we are doing here, this part is for finding the GCD of the array. Now, if n greater than 1, we are arranging them in this sequence: 0, G, 2. There are some better implementation also, but for the simplicity, I have maintained this array: 0, G, 2G, like that. Now, coverage means that the number of elements we have covered. So here, up till this, until this, we have covered one element. So that will be, coverage will be 1, and current means what is the current element. Okay. Now we are checking that coverage plus ei minus card is nothing but G, so you can use G also. If coverage plus G minus 1 is greater than equals to K, then we are selecting answer as current plus K minus coverage, and we are breaking from the array. Now, if there is some case, for this case only, that if the value of K is 5, then we are not finding them in the intervals. So then the answer will be -1. So if answer is minus 1, we are doing answer equals to answer car plus k minus coverage. Okay. So this question is quite straightforward. Just we have to understand that we can make the given array in this sequence 0 2G like that, and after that the problem becomes quite straightforward. I hope you got the explanation and the code. I will provide the link of the code in the description box. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. If you find this video helpful, please like the video and subscribe to my channel. Thank you.